Hello, algebra. We are going to switch gears. We're going to go back to graphing, and we're going to graph what makes this really cool thing. We're going to graph quadratics, quadratic equations. So first of all, we need to look at this. So y equals x squared plus 5x minus 3. What does that, we need to think about what we're doing with this. And this specific equation, or look of an equation, is called a quadratic equation. Why is it called a quadratic equation? Because it has the exponent of 2. So because this x has a square on it, it makes it a quadratic equation. Okay? So we've got squared without an exponent and then a constant. That format is what we're going to be graphing in this part of the chapter. Okay, so every single time we graph one of these, this is called a parabola. And so when we're graphing a quadratic, we're always going to be graphing a parabola graph, and it is U-shaped. It's not pointed down here, it's a U, and it can go up, a U-shape up, or it can go a U-shape down. So it can hold your tea or it can spill your tea, okay? And that's going to be important as we look. So this is the graph for that equation, y equals x squared plus 5x minus 3. So let's take a look at y equals x squared, just x squared with no numbers with it, and see what that looks like, okay? We are going to look at and learn how to find the vertex. Here's my vertex. So my vertex on any parabola is my highest point or my lowest point. In this case, that's my lowest point. If my parabola was spilling my tea, it would be my highest point. Okay, so here, this vertex on this graph is my lowest point on my graph. So as I go down and look at this, it's my lowest point. All right, where is that lowest point? If I were going to graph that, where would my lowest point be? Well, here's my origin, so it would be at 0, 0. Right? When we're graphing these parabolas, we need to be able to start with our vertex. We have to have a starting point like we had our y-intercept, right? If we're doing a line, what was my x value? Y equals mx plus b. My exponent was only a single x, right? Okay. Now, one other thing that you'll notice is that every parabola can be folded in half. So you see this line I drew on the y-axis? If I folded it in half right there, here to here, it would land on itself, and that folding in half, the line that it can be folded in half on, is called the axis of symmetry. In this case, my axis of symmetry is at x equals 0. It's always going to be an x value, my axis of symmetry, and it's always going to be whatever my x value in my coordinates for my vertex is. Okay? So, moving on. A little bit more terminology and how things work in a parabola. All parabolas follow the same pattern. You'll notice if you start at the bottom here, to get to this point, you had to go over 1 to the left and up 1. Over 1 to the left and up 3. Notice on the other side, it's the same pattern. Over 1 to the right and up 1. Over 1 to the right and up 3. Is that true for those other two graphs that we've looked at? It sure is. If I go over 1 to the right and up 1, this should be down further. That should be on the axis. Let me use the other one because it's graphed better. Here, if I went over 1 to the left and then up 1, I would get to my next point. And I would go over 1 to the left and up 3, I'd get to my next point, and over 1 and up 5. So if that's the pattern that I'm following, what do you think the next two numbers would be? Over 1 to the left and up how many? Well, plus 7, and then what will be my next one? Plus 9. So my pattern, every single time I am doing a parabola, graphing a parabola, is I'm going to go over 1 to the left, up 1, 1 to the left, up 3, up 1 to the left, up 5, 1 to the left, up 7, 1 to the left, up 9, and so on. I'm going to just be counting by odd numbers as I'm going. These are called our building numbers, and these numbers are important that we can identify them so that we have the pattern correct as we're graphing, because we're going to start with our vertex and then we're going to follow our building numbers to be able to graph. So let's look at that one more time. You can see the building numbers here. Here's my vertex of x squared plus 3. Here's my vertex. I went up 3 and put a dot, and then I went over 1 to the left, up 1. Over 1 to the left, up 3. I'm hoping that you can see that. And you do it the other way too. Over 1 to the right, and it's always from the vertex, okay? We don't start back down here at the origin. We always start at the vertex and then do our pattern. Same thing here. I've got x plus 3 squared. It's a parabola. I know that because it's a quadratic. My x thing, or my x term or expression, is squared. So I'm going to go over to 3 and put my dot. We'll talk about how to find the vertex in just a second. And then from my vertex, over 1 to the left, up 1, 1 to the left, up 3. Then I ran out of room. But if I didn't run out of room, I would go over 1 to the left and up 5, right? And then I do the same thing going to the right. 1 to the right, up 1, 1 to the right, up 3, 1 to the right, up 5. Okay, see the pattern? I hope so. So let's look at a little bit more terminology. So we're a little terminology heavy today, but that's okay. So we're going to learn how to graph some ourselves. To do that, we're going to put things into what's called vertex form, which means it's really easy to find our vertex from this, because as you can see, my h and my k from this form are defined by the form itself, okay? So I've got y equals a, so that could be any coefficient. Often it's 1, sometimes it might be negative, sometimes it might be a number, and that'll affect how our graph looks, skinny or fat. We'll talk more about that later. But we can find our vertex. Our vertex is our h value, that makes up our x value, and our k value in our equation makes up our y value of our vertex. So, in this case, what's my vertex? Well, let's look a little bit at some rules. We're going to start with our x value. Sorry, there we go. We're going to start with our x value, and our x value is always, I'm going to read you what it says on your sheet. Mine's a little bit different. It is, the x value of the vertex is always what makes the inside of the parentheses equal to 0. Equal to 0. In other words, opposite of the math behind. So it's always the opposite of x. Okay? Of what's with the x. So, opposite of the math behind the x. So what does that mean? In this case, it's minus 3 is behind the x. So what's the opposite of minus 3? Well, positive 3. So my x value is 3. okay? Now, I said that it has to be the value that would make the inside of the parentheses equal to 0. And that's kind of how we calculate our y value until maybe we see a pattern, okay? So I put my 0 in there. I put my 3 in there. And 3 minus 3 is 0. 0 squared plus 1 gives me 0 plus 1. And 0 plus 1 is y equals 1. Okay? So in this case, my opposite of my x value was 3. My y value in my vertex is 1. Look at this. It's always going to be that. So you don't even have to do this calculation. You can simply figure out what your y value is by looking at this. So we're going to start graphing with our vertex, and then we are going to find our axis of symmetry as well, okay? So, starting to graph with our vertex. What was my vertex? Well, it was 3, 1, because the opposite of this behind the x would be 3, and my y value is 1. So I have to go to 3, 1. So I go over 3, up 1, and I put a dot. Okay, now I need to graph using my building numbers. I like to go left first. Doesn't matter if you go left first or right first, but you're going from your vertex. Remember I said you need to go over 1, and then you need to go up 1 from that. So over 1, up 1. Now you're going to go over 1, up 3, and put a dot. So here's your over 1, up 1. Over 1, 1, 2, 3. It's going to end up at 5. Over 1, up 5. 1, 2, 3, 4, 5. We'll end up there. Okay? So now how do I do the other side? I do the same thing, but I go to the right. Over 1 to the right, up 1, put a dot. 1 to the right, up 3, put a dot. 1 to the right, up 5, put a dot. Do I even need to count those? I don't, because look, they're right across from each other. Okay? So I don't really need to count them. I need to do one side well. I need to go over 1 and then up to where this other dot is. Over 1 up to where this dot is and go from there. Okay. I don't necessarily want all that stuff on your graphs. Okay. Now I draw my U. Make sure that's not a V on the bottom. Make sure it's a U. Okay? Here we go. Let's see. Let's do one more on an example. And I am looking at example number 1. What's my x value? So this is a -1, so what's my x value going to be? +1. What's my y value going to be? 4. Ooh, I forgot to do the axis of symmetry over here. So where would my axis of symmetry be? Over here. Where, when I fold this in half, it's going to be x equals 3. And my axis of symmetry always comes from my x value of my vertex. All right, so I need to graph 1, 4. Over 1, up 4, put a dot. From there, I'm going to go over 1, up 1, over 1, up, not up 1, over 1, up 3. 1, 2, 3. And then I'm kind of out of room, okay? Over 1 to the left, up 1, over 1 to the left, up 3. 1, 2, 3. And that's it. You just follow the same pattern over and over. If I fold this in half, where am I going to fold it? At x equals 1. And that's my axis of symmetry. Okay? Let's try number 2. Y equals x squared minus 3. What number is being added to my x in this case? Correct, nothing. So what's opposite of nothing? Well, nothing. Okay, what's my y value going to be? It's going to be negative 3. Okay, so I'm going to go over 0, down 3, which doesn't work on the graph that I have, but I think it works on the graph that you have on your paper. So I'm just going to go down 3. 1, 2, I got to move this down just a little bit and make that work for me. Okay, 1, 2, 3. I'm going to be about right here. And then I'm going to go over 1, up 1, over 1, up 3, over 1, 1, 2, 3. That's enough. Over 1 to the left, up 1. Over 1 to the left, up 3. 1, 2, 3. Okay. Connect my U. Done. Where am I going to fold this? If I fold that in half, my axis of symmetry is at x equals 0. Awesome. We got 1 left. Okay, what's my vertex? Well, what number is opposite of what's attached to the x? Negative 5, correct. What number is being added to the outside? I'm hoping you said nothing. Nothing meaning that's a 0. And then how do I graph this? Negative 5, 0. So I go over to negative 5, 0. From there, I'm going to go over 1, up 1. Does it matter if I go up, over to the left or right first? It doesn't. 1, 1, 2, 3. So that'll put me right there. Over 1, up 5. 1, 2, 3, 4, 5 puts me right there. Okay, so other way. Oops, go away. Over 1, up 1. Over 1, up 3. 1, 2, 3. Over 1, up 5. There we go. Try to get through there. That's it. That's what we've got. If I fold that, where am I going to fold it? X equals what? Negative 5. And that's our notes, my friend. Please do your worksheets. Remember, this is opposite. This is whatever's being added to the squared term. And this is my x value. God bless.